We start with the first equation of the system.
Here is the second equation. Since both equations contain reciprocals, substitution will help. Before changing anything, keep the original restrictions. The denominators mean x and y cannot be 0. Let u equal 1 over x and v equal 1 over y. This turns the system into a linear one. The first equation becomes 4u plus 6v equals 0. The second equation becomes 3u minus 4v equals negative 17/6. To eliminate v, multiply the first linear equation by 2. Now, multiply the second linear equation by 3. Be careful with the sign on negative 4v. Adding the equations cancels the v terms, leaving 17u equals negative 17/2. Divide both sides by 17 to get u equals negative 1/2. Now substitute u equals negative 1/2 into the first linear equation. 4 times negative 1/2 is negative 2. Add 2 to both sides to isolate the term with v. Divide by 6, so v equals 1/3. Since u is 1 over x, 1 over x equals negative 1/2. Taking the reciprocal gives x equals negative 2. Since v is 1 over y, 1 over y equals 1/3. Taking the reciprocal gives y equals 3. A quick check in the first original equation gives 0, so it works. The second original equation also checks out. This confirms the algebra. Therefore, the solution is the ordered pair -2, 3. And we keep the original restrictions. X and y cannot be 0. These are not lost after substitution.